Okay, so if you can find what information is given and what's missing, then realizing these are for your benefit to better solve those problems, to more quickly say, I can use one of these equations because acceleration information is not given or time information is not given. Now, as you get used to doing these problems on the worksheet, to set those up, put those answers in, what's going to happen is we're going to get to a place, and you've had that practice now, that you want to see some special kinds of motion. One of those special kinds of motion is going to be motion of anything that is falling freely but is moving on its own accord, like a plane, for instance, that's coming in for a landing and it isn't being accelerated anymore. It's just freely falling, hopefully not so fast, but it's got its forward momentum. Maybe a plane is a bad example. Frisbee, let's take a Frisbee. As that's going, it's flying freely and it's free to fall. A football or a baseball is going to be an example of something that's in projectile motion. Anything that's thrown, from a catapult stone to a bullet to a car jumping over some kind of a stunt. Bicycle that's doing the same. If you're jumping out of a boat and onto shore, for instance, all of those are going to be this sort of projectile or two-dimensional motion. You are free to fall, but you also have some velocity forward or not. Now, even before we start those motions, what's true about that motion? If you're free to fall, you're going to be falling based on a known amount. As a matter of fact, gravity, when it pulls you, has an amount that makes you fall faster, about 10 meters every second, faster than the previous second. So Earth's gravity pulls us at 10 meters the first second, and then 10 meters faster at 20 meters per second. And then if you fall for 3 seconds, you'll be moving 30 meters per second. So every second you fall, gravity assists and adds 10 meters per second velocity. The exact number is 9.8, and we'll probably use this. But if you can remember 10 on many of these problems, there'll be some that are going to simplify it for you, so you can just think about those until you get used to that term. 10 meters is a good way to think about those. But if that's true, that's the acceleration whenever we're on Earth, is that there's going to be a 10 meters per second fall. Your velocity, on the other hand, of you moving forward is going to be set. And if you're flying in space or you're jumping between buildings or there's some bicyclist that's going there, there's nothing adding to your velocity. Okay, you can't be in a jet, that's why, or a rocket or something where you're adding to your velocity and have acceleration in the x direction when you're flying. So that's typically not thought of as a projectile. And so what's nice about that is that these two motions can be separated, and then you can solve problems fairly easily. You can just say, the velocity I can just solve by saying it's the change in position over time. Most of the time you are going to know your initial velocity because you're going to start from stopped and you're falling, for instance. You may know, it may be given that you know what your velocity is in that initial kind of area. And you know your position. Now, instead of x that, obviously if you're falling, you're going to be thinking about y, your up and down position, velocity, acceleration, and time. So it's the same set of equations, but use the two y parts, your final height and your initial height. This is the velocity times time. That's how far you can go in a certain time. And then it's going to be guided by accelerating. You're changing motion from the acceleration to the Earth. Now, it's true when you start off, a lot of times you're going to drop something from a building or whatever else, and you want to see how far you go. Then the final velocity is all you're interested in. You're going to say, hey, I'm starting from a building, how high? I know my initial velocity is 0, so then this is all that's left. Your how far you fall becomes 1/2 of gravity times time. Now, when you use the exact number, it's going to be your falling distance is 4.9 times the time you've fallen. Okay, so you can use that as an equation. That's going to be telling you how far you fall at a certain time. Let's do a couple of problems so that we see how this works. The first one, let's take an object. Let's say somebody's golfing up here, okay? And they've got their golf ball. And that gets knocked straight outwards. And we want to say, how far is this ball go? Okay, in a certain time. Now, if we know this hill is, for instance, 20 meters tall, and we know this distance, $600 seems like a long way to drive a golf ball. Let's make that more like 200. Okay, 150, 50. We're two separate units, right? Meters. Okay? A lot of times the question was, how fast was that ball driven? So you're going to get some kind of question. And the key to solving these, because they're two different systems, one is an X kind of a motion equation and one is an up and down equation, is recognize what is the question that's being asked. Is this an up and down question, or is it a left and right question? This is saying how fast was the ball driven. So that is what kind of a question? This is a question here. What was the velocity in the X direction? That's an X question. And since these are independent, my strategy for you when you do these is to say, if you know what the question is in the X direction, in the horizontal, then solve the other equation first. This is just a ball dropping to the ground. So you're going to start, whenever you get a question that's in the X, you're going to start with the Y part of the equation. And you're going to say, what is the general form of the equation? Because that's what always governs free fall. You can say how far this thing falls, Y final minus Y initial, has got to equal the velocity in initial times time, plus 1/2 minus 9.8, or we'll just use 10 just because that's a nice even number. If we can, that would be great. Okay, 10 meters per second squared is how fast things fall. Okay, we know what the initial velocity is in the Y direction. It's starting here, it has no velocity downwards, so that's going to go to a big 0. We know what the initial height, well, we know what the initial height is. That's going to be 20 meters. And we know what we're trying to get down to, the final height, which is 0 meters. Okay? Now, we also know that that minus that's going to end up working this out is still plus 1/2 acceleration squared. AT squared times, sorry. So we still have to sneak a t in there. So this is going to be 1/2 of 10. This is going to become a minus because I've got a minus inside there. And I've still got a t squared. I got to sneak that in there, don't I? Okay. Now, this just becomes a minus 20. This becomes 5, minus 5t squared. So t squared is just equal to 4. That minus, I divide both sides by 5, that becomes 4. T squared is this. So that thing took 2 seconds to drop from here down to there. That is the first step. I answered the Y part of the question. Now I can answer the X part of the question. How fast was the ball driven? Because velocity in the X is equal to the change in position over time. And you just solved for time right here. This is going to be 150 is the distance the ball was driven. And it took 2 seconds to fall that. So the velocity when this came out is what? It's 75 meters per second. So my suggestion to you when you see these problems, when you're doing free fall problems, which you're about to do some problems of that, this will be the second assignment for you, is to say, what kind of question is this? Is it an X or Y? Is it vertical X or is it up and down Y? And if it's X, solve the problem, set up the problem in the Y. Figure out how much time it takes to drop that distance or change those heights, find that time and use it in the other equation. Okay, if it's a Y question, if it's an up and down question, then solve this part of the equation. It's usually given enough information, and then use the time to put it into this equation. So you really have 2 equations here. Let me sneak that over. Okay, you'll have a Y part, and here's the X part. Once you solve those, you'll be good to go. Okay, give those a try. I'll set those up for you in the download area.